Welcome to Jam Physics class. So we are talking about type of machines. This is going to be the second video on machine. So we're about type of machine. Our point of focus is going to be the pulley or block and tackle system, which is this one here. It's okay. Now it's going to be the second video on machine. I've done the first video. What is machine? The various terms. In the various terms, machine we talk about mechanical advantage, velocity ratio, and efficiency, right? We derive those formulas for efficiency and we solve a lot of problem on what on machine, the introductory aspect. So please kindly go check out the first video because the first video is very important. Just so we have your type of machine, but in this video here, I'm going to talk about what the pulley or block and tackle system. Just remember, machine is what enables us to do to overcome a large load when small amount of effort is being applied. Do you understand? So example is the wheelbarrow. Do you understand? Where you carry like want to carry like three bag of cement, right? So instead of carrying those three bag of cement in your head, which require lot of effort. Do you understand? Now which require a lot of effort. What you want to do here is to carry those three bag of cement into what wheelbarrow. They just apply little effort and what roll it. Do you understand? So machine makes us to overcome large work, large loads with small amount of what of effort. Just so anything that make our work easier for us, we call it what machine, we call it system that enable us to do more with less effort. Just that is called machine. And one total machine is called the block and tackle system. This is where you use now. This is the effort. This is the effort. This is the load you want to overcome. So if you say that now, let me just say this load is much, so but you want to raise it, you use the pulley system. Once you apply little effort, you can raise this what load here. Do you understand? So now you have to call the mechanical advantage. Mechanical advantage. Mechanical advantage is always equal to what load load over what effort. Idea which is equals to what load over L over what E is okay. That is called mechanical what advantage. Now we have called velocity ratio. Velocity ratio is equal to distance moved by effort over distance moved by what load. Distance moved by effort over distance moved by load. Idea which is equals E over what L. E over what L is okay. Now, but when it comes to what the pulley system here, the velocity ratio is the numbers of what pulley. Idea. So in the tackle system here, once you are being given the block and tackle system, the numbers of pulley is the velocity what ratio. Do you understand? So in the what pulley in the what block and tackle system here, velocity ratio is equal to what numbers of pulley. Numbers of what pulley. Either these are the what numbers of pulley. 1, 2, 3, 4. I think it can be 3. I think it can be 2. I think it can be 5. I think it can be 6. It can be 7. Depending on the type of pulley what you are using. Just so this is what you want to pay close attention. Then my efficiency equals to what is equals to what mechanical advantage over what velocity ratio times 100 over what 1. So now this is the stuff we are going to use here. Just so this formula we are using. This is that. So what I want to do here, whiteboard, so I can solve this one. But this is what question 1. Let's solve this question 1. So let's solve the question 1 here. The diagram below represent. Look at the diagram below here. The diagram represents a block and tackle pulley system on which the pulley system. Okay, this thing I wrote it twice, right? The diagram below represents a block and tackle system on which an effort of 15 newton here is just able to lift a load of weight, right? If the efficiency of the machine is 40%, find the value of W here. So now instead that you apply this effort here to overcome this load. The load is the what? Is the weight. The load is what is the weight. The load is the weight. Do you understand? So now my effort. So my effort, which is the E, because what 50 what Newton is okay. Now my efficiency. Sorry, my efficiency. This is the efficiency here. Efficiency. This is symbol of efficiency. Efficiency equals to what? 40%, right? 40 what percent. Now, what they say should calculate here? They say should calculate what? The load. No, which is not the weight. The weight is the load. Do you understand? The weight is what is the load. Do you want to understand here? Now, what my velocity ratio VRO is what numbers of pulley 1, 2, 3, 4, 5, 6. So you are what 6. Do you understand? So now therefore, for me to calculate the load, I need what my mechanical advantage, which is what WA equals what load over what effort, right? So it is said that if I can know my mechanical advantage, I can just multiply what with the effort, right? By making load the sort of formula. So we're going to be load equals to what mechanical advantage times what effort. This is that. So the idea here now is to what make is to what calculate what my mechanical advantage. Remember, efficiency equals to what mechanical advantage over what velocity ratio times 100 over what 1. So let's make mechanical advantage subject of formula here, right? If you want make mechanical advantage subject of formula here, remember here is over 1. Here going to be mechanical advantage times 100, right? So going to be mechanical advantage equals to 100 mechanical what advantage, 100% here over what velocity what ratio. When you cross multiply mechanical advantage here equals to what efficiency times what VRO over what 100, right? So now let's substitute what our values here. So my mechanical advantage equals to what my efficiency is what is 40 times my VRO is what is 6 over what 100. What 2.4 is okay. 2.4. So my mechanical advantage equals to 2.4. So yeah, I've already calculated what my mechanical advantage is 2.4. So my load equals to what 2.4 times my effort is what is 50, right? You got to be what 120 Newton when you multiply. Do you understand? That is the load here is what is 120 Newton. So you need a force of you need a what an effort of 50 Newton to overcome work of what 120 Newton. Do you understand? So let's solve on that example here. But before we go here, let me change this value here. Let me now let's say here we have 35 what Newton and here we have 56 what percent. Is okay? So go ahead and solve this question for me. You understand? I've just shown value here. Go ahead and solve this question for me. If this video is helpful, please leave a message that this video is helpful, right? So let's take some other question. Okay, now let's solve these two questions. Example 2 and example 3. Now, in each of my video here, I really want to explain every single details. So by the time you finish watching the video, you should be able to tackle any problem you see anywhere. Do you understand? So that is the idea of my video, because I don't trust you to go and be reading more. Do you understand? Although it's very, very good after this video here, go and tackle more questions on this particular topic we are doing. Do you understand? So now let's carry on this example here. They start the velocity ratio and the efficiency of a system of 7 and 80% respectively. How much effort is required to lift a load of mass 120 kg with this system? It's very easy here. My velocity ratio here, which is what VRO, my velocity ratio is what is 7. My efficiency is what is 80%, right? Now, the load of mass. So the mass times the mass equals to what 120 kg, right? But the load, for you to get load, because what the mass times g is okay. That's how to get load, because the load is actually what the force because of what mass times acceleration due to gravity. Do you understand? So That is my load is going to be what? 120 times my G give to me is what is 100. It's 10, right? Going to be 1200, right? Uh, Newton. So my load, here I can say what my load is what is 1200 what Newton, right? Now what they say should calculate, they say how much effort. So they ask you to calculate what the effort, which is what is the E, is okay. So now how do we calculate effort? How do we calculate effort? Remember, uh mechanical advantage is equal to what? Load over what? Effort, right? So from here, from mechanical advantage, that is where you can easily what get your efforts. Just and so if you want to make effort the solve formula here, my effort goes to what? Load over what? Mechanical what? Advantage. This is that. So how do you calculate what mechanical advantage? We are going to use efficiency equals to what? Mechanical advantage over what? Velocity ratio times 100 over what? 1. Making what? Mechanical advantage is subject to formula. Here we have mechanical advantage equals to what? Efficiency times velocity ratio over what? 100. Hope you understand. It's very easy. So for the parameter given to us, that is where we know how what the stage calculates. So from there now we know the formula to you can use to calculate the effort from the mechanical advantage. So if I can get what I already know my load, once I get my mechanical advantage, effort is very easy. So how do you calculate what my mechanical advantage using what? Efficiency. Mechanical advantage over what? Velocity ratio times 100 over 1. So making mechanical advantage solve formula, this is what you're going to get, right? So what I want to do now is to impute what your values. So my E is what is 80 times V is what is 7 over 100. So going to be 80 times 7 divided by 100. Here we have 5.6. So my mechanical advantage now is equal to what? 5.6 is okay. So from there now, let's calculate our effort. E equals what? What is my load? My load, which I've calculated, is what? 1200 watt Newton over 5.6 is okay. So 1200 divided by 5.6, here we have what? 214. So my effort is equal to 214 Newton. Just that. So in the sense that I need for me to overcome a load with a pulley of 7, I need an effort of what? 214 Newton. Do you understand? So you can see that the load is far bigger than what? Than effort I'm putting. Do you understand? That is what that is the work of a machine. The work of a machine is to what? Make things more easier for you. Do you understand? So if I should change this value here, now let me say here we have 5, and here we have 95%. Is okay. What will be the answer? Now let us say here we have 150 odd kg. So what will be the answer here? So I've changed value. Make sure you want to solve it, right? So let's look at question 3. Let's solve question. A block and tackle system is used to lift a load of 20 Newton through a vertical height of 10 meters. If the efficiency of the system is what? 58%, how much work is done against friction? How much work is done against friction? So you can see that this particular question is totally different from the two set of questions we have done. It's a little bit confusing, right? So, but now let's look at the question very well so I can know how to tackle it. Is that a block and tackle system is used to lift a load. So my load, which was L, is equal to what? 20 Newton, right? Through a vertical distance. So distance moved by load, right? Remember, we have called load. We also have called distance moved by load. So load is what? Is L. Capital letter L is what? Is load. Small letter L is what distance moved by loads, right? So whenever you see L is what is the load itself, load. The small letter L is also distance move by what? Load. This is that. So my load is what? Is 20 Newton. Now the distance moved by load, which was small letter L, is what? 10 meter. 10 what? Meter. You also have called effort. Which is E. Effort, We also have distance moved by effort. Do you understand? Distance moved by effort, which is small letter E. Distance moved by what? By effort. So, but they say anything like the effort and distance moved by effort. So we have to ignore this one here. This one is none of our business here. So we ignore it. Now they give us efficiency, which my efficiency here is what? Is 58 what percent, right? So then I ask you, how much work is done against friction? How much work is done against friction? So they're asking you, what is the work input? Now, remember I told you something here that efficiency is equal to what? A mechanical advantage over velocity what ratio times 100 over what 1, right? Now, my efficiency equals to what? Work output. Work output over what? Work input. Right there. Times what? 100 over what 1. Is okay. So this is formula we are going to use here. Work output over what? Work input times 100 over 1. My work output is like the load you overcome. See, work output, we talk about work output because what? Load times distance move by what? Load. Is okay. Now this is what you want to understand here. So work out means what? Load. Remember, you put in effort to overcome the load, right? So the effort is the input, right? The load is the output. Do you understand? So we talk about work output, we actually talk about load times distance moved by what? Load. Then work input because what? Effort times distance move by what? Effort. This is that. So in saying that, to get my work output here, I will just say load times distance moved by load. Do you understand? This is what they actually say to look for. So what they actually want us to look for is what? Is how much work is done against friction, right? The work you put in to overcome the load. Do you understand? The work you put in, which is the effort you put in, right? So remember, work input is equal to what? Effort times distance moved by what? Effort. Work output because of load times distance moved by what? Load. This is what you need to understand. It's okay. So with this now, yeah, I can just say, can I write this one again and say what? E equals to what? Work output over work input times 100 over what? 1. So from here now, let me calculate the work output first. So my work output here, work output equals to what? Load, right? Load times distance moved by load, right? The load times distance moved by load equals to what? 220 times what? 20 times 10, which is what? 200 what? Joules. Remember, the unit of work is joules, so it's going to be joules, right? So now we want to calculate work input. It's okay. So to make this guy the subject of formula, you're going to be work input equals to what? The work output times 100 over what? Efficiency. This is that. So if you should impute the value here, work output here is what? Is 200 joules times 100 over my efficiency is what? Is what? 58. It's okay. So here we have 344.8. 344 point what? 0.8 is okay. 0.8. This is at 344.8. So that is what? Work input. Now, but when I say to calculate work done against friction, work done against friction. So the work done against friction. So they say work done against friction. So here is formula for work done against friction. Here is formula. There is formula I did tell you before. Work done against friction. Again, work done against friction equals to what? Work inputs minus what? Work outputs. Is okay. Work inputs minus what? Work outputs. So the work done against friction now is now going to be equals to what? My work input is what? 344.8 minus work output is what? Is 200, right? So what will be the answer? 344.8 minus 200. So we have 144.8 what? Joules. That is the answer. So now when you say work done against friction is always equal to what? Work inputs minus what? Work outputs. So this formula is very, very important. So please take note of this formula here. It's okay. This is the most important formula here. From there, you know how to what? Solve this question here. So now let me just change this value here. Let us say here we have what? 35, right? Let's say we have 35, and let's say here we have 15 watts meter, right? Let's say the efficiency is what? Is 68, right? So what will be the answer here? What will be the answer? What will be the answer? So go ahead and solve this questions here. Leave the answer at the comment section. So we are done with this class. Thanks for watching. See you in my next video.